Hello, in this video we're going to look at standard deviation in our topic of statistics. So let's think about what we do know first. We've been through range and IQR, the interquartile range. So what are they? The range is the maximum, take the minimum value. Now, because this uses the largest and the smallest values in the data, it can actually be really distorted by outliers that may be present. The example I'm going to get you to think about through this video is basketball and the average number of goals scored per player, let's look at. And so then when we're looking at, say, the average amount, they could have a really bad game and they score none, but then they could have an out of this world game, maybe playing a really bad team, but that might not be a great representation of what happens on average. And so that's why the range can be really distorted by those outlier values. The interquartile range, the IQR, now that's found by finding the Q1 and the Q3. You remember how to do that. If not, go back and have a look at some of those other videos. And now that does involve all of the data values. So that's a better representation, because it's not so affected by those two single values, which would be the maximum and the minimum. But what else have we got? The other comment here, so that if the data has outliers, the IQR will be a more reliable measure of spread than the range. And that wording about more reliable, more consistent, that's the sort of language we often use here in statistics. Okay, so standard deviation. What do those words even mean? So in terms of measuring the spread of our data, we've talked about how the range, that's the maximum, take the minimum, can be distorted. Now the IQR, that's less affected by those outliers, but if you remember when you do a box plot, it's only that middle 50% that it's talking about. Now standard deviation, SD, that's often abbreviated to, that's more accurate. If you're doing the formula by hand, it's much more difficult to find, but that's why we use our graphics calculators. So starting to think about those words, standard deviation, what could that be meaning here? So it's a set of data that's the average distance of all the data values from the mean. So standard means sort of a standard amount, if you like. Deviation, how have you heard that word before? To deviate means that you break away from something else that's happening. If you deviate from the norm, from the normal, you might be different to what the majority of people do. And so is there an average amount that things can change from the mean? So what I mean by that is, thinking back to this basketball example of a player's average score, when they're looking at their games across a season, is there an average amount that one single game can deviate by? So the further away from the mean it is increasing, that means that that's, better games. And obviously you can have games where you score less goals. And so they're deviating away from the mean, they're moving away, and there's an average amount that happens. So how is this calculated? First of all, the higher the standard deviation means on average that our data then is more spread out. So if that basketball player had a standard deviation with a high number, what would that mean? It means they're not very consistent with the number of goals that they're scoring on average each game. If they had a smaller standard deviation number, so let's say the average goals was 10 per match, if you have a standard deviation of, say, only 1, then that would mean you're really consistent each match, and that you are deviating from that by 1, which is not many. In further videos, we're going to talk more about how 3 standard deviations is a measure of trying to capture most of our data. But if that person had a standard deviation of, say, 3 or 5, then that means each match they might vary that much from the mean, and so they're less consistent. So that's some of the language that we use here in statistics. Now, how do we find this? So there is a formula to do this, but we're going to use our graphics calculators here for this Year 11 General Maths course. Now, it's actually given as part of the summary statistics that you're already used to doing when you were finding the mean and the IQR and the 5-number summary, So when you see it on your calculator there, look for SX. So the S is for the standard deviation. And remember that when comparing two sets of data, a lower standard deviation, you could say that they're more consistent. So there's the language to use. Let's go into an example. So Conan, he selects a random sample of 12 comedy movies and 12 action movies and records their running times. And so how long they went for. As you can see here, 12 comedy, 12 action. So a question that you might get asked about this is to find the sample mean and sample standard deviation for each movie type. I encourage you, grab your graphics calculators, pause this video, type these in. You can type this into list 1 and the action into list 2. And then just like you would try and find the mean by calculating the one variable statistics there, go and do that. Pause the video and get that up on your screen. So I'll assume you've done that. And you'll probably be doing it one at a time. And so the X bar, as we've talked about before, that's the symbol for mean, and 108 minutes for comedy. And if you'll see on the screen there, your S is about 8.36. These numbers would round. Right next to that, I think it's above, you will see this symbol here. And that's another similar 8 number, 8.00867. That's not the one we use. So the word for this is sigma, and sigma, that's a letter in the Greek alphabet. That's the lowercase letter for sigma, and that's what we use for the population standard deviation. But don't worry, we're not going to use sigma. We're using the S for the sample. Other parts of this question you might be asked to do then is which type of movie generally had a longer running time. So which of these 2 bits of information will we refer to for that? The mean for this one. So let's put our numbers back up on the screen here. So the mean there, the average, which had a longer running time, well, you're comparing these 2 numbers, the 108 number and the 133 number, which is longer. This one, 133, so your answer to this part would be action. And then the second part, which had a smaller spread of running times. And that's when we look at the standard deviation. So that word spread, that should be a key to you. I need standard deviation. So the 2 S values that you found on your calculator, one was 8.36 and one was 14.2, which had the smaller spread. You look at the smaller number, this one here, and then so your answer for that would be comedy. And so what have we found there? What do these 2 standard deviation numbers mean? It means that although action movies run for longer, their spread, their standard deviation number is bigger. So that means you're more likely to have action movies with really quite different times from that 133. It could be less 14 minutes or more than 14 minutes. And so that's a bigger spread, whereas the comedy, 108 minutes and might only vary by 8 minutes less or 8 minutes more for the majority of those movies. Okay, the problems that match this now are 9i. Give those a go. Thanks for joining me.